बात करते हैं केमिकल इक्वेशंस कैसे रिप्रेजेंट किया जाता है। सिंपली केमिकल इक्वेशंस को हम दो तरीके से रिप्रेजेंट कर सकते हैं। फर्स्ट इज अ वर्ड इक्वेशन एंड सेकंड इज अ केमिकल इक्वेशन। वर्ड इक्वेशन में आपको नेम ऑफ द एलिमेंट्स लिखे हुए मिलेंगे, जस्ट लाइक मैग्नीशियम। अगर हम इसको केमिकल इक्वेशन में रिप्रेजेंट करें तो इट इज़ represented in the form of a symbol like Mg. So the Mg is the symbol of magnesium. Oxygen is written here in word equation, but O2 is a symbol for oxygen. Simply the oxygen is represented by O, but the molecular form of the oxygen is represented in the form of O2. Both magnesium and oxygen combines to form magnesium oxide. मैग्नीशियम ऑक्साइड इज़ रिप्रेजेंटेड बाय MgO एज पर द वैलेंसी। आप सोचेंगे कि Mg प्लस O2 combines to form MgO2, but this will be incorrect. It will combine as per the valency of the substances and it will form MgO. These substances such as magnesium, oxygen and magnesium oxide, in the left hand side of the arrow, all the substances are considered as reactants. All the substances are considered as reactants, or more appropriate, substrate and reagent. Substrate and reagent combines to form products on the right hand side, and these reactants and products are separated by the arrow. This arrow mark is represented in the forward direction. Sometimes the arrow should be like that. This type of arrow indicates the reversible process or the reversible reactions in which reactants can be converted into products and products can be converted into reactants again. So this is the simple representation of a chemical equation. The representation of chemical reaction in the form of formula of the reactants and products. These are separated by an arrow mark, that is single-headed arrow. This is called chemical equation simply. Now what is the need after writing the chemical equation? So we need to balance the chemical equation. How to balance the chemical equation? We need to balance or equalize the number of atoms present on the left hand side and right hand side. If one magnesium atom is the left hand side, so one should be on the right hand side, but oxygen atoms are 2 in the left hand side. So this MgO should be multiplied by 2 to equalize the number of atoms on both sides. So after indicating the digit 2 in front of the magnesium oxide, we need to balance the magnesium atom in the left hand side. Now 2 magnesium atoms on the left and right and 2 oxygen atom on the left and right. So this equation is balanced easily by normal method. This is the manual method, or you can balance the equation by taking the more complex formula in the given equation. Now the complex formula in this equation is magnesium oxide. So first of all you need to balance the number of atoms. Like magnesium is equal but oxygen atom is not equal, so we have to put the digit in front of the formula, and after that we will balance the magnesium atom simply. So this is the balancing of the equation. So the same number of atoms of each element, same number of atoms on the left hand side, that is reactant, and right hand side, that is products. This is the balanced chemical equation. So this is our balanced chemical equation. Now the second equation is given here. The second equation is iron, represented by Fe, along with water, H2O, iron combines with water to give ferric oxide. Ferric oxide is Fe3O4. It is the oxide of iron. Ferric oxide has Fe3 positive. Ferric oxide contains Fe3 positive along with H2 gas. Now we need to balance the equation. First of all, we have to pick up the complex formula in the given equation, that is Fe3O4. Now number of iron is 3 here, so we have to write 3 in front of the iron atom. Oxygen, 4 oxygen atoms are there, so we can put it in front of the water molecules. So 4 water molecules are there. Now we need to balance the hydrogen atoms. So total of 8 hydrogen atoms, 4 multiplied by 2, 4H2, it means total of 8 hydrogen atoms. In the left hand side, 4, so total of 8 hydrogen atom in the left hand side. So we need to put 4 in front of hydrogen atom to be 8 hydrogen atom. So 3 iron atoms, 4 oxygen atoms and 8 hydrogen atoms on the left and right hand side are equal. Now the final equation, 3 iron atom and 4H2O gives Fe3O4 plus 4H2 is the answer of this equation. Now you can see the answer of this equation, that is written here. 3 iron atom, 4 H2O molecules gives ferric oxide along with 4 moles of hydrogen gas. Now this equation is balanced. We have the following examples along with their physical states. Now iron is present in the form of solid, water in the form of liquid, iron oxide is in the form of solid, and H2 is in the form of gas, that is represented by the arrow. This gas is escaping out from the container. Next example, carbon monoxide is a gas. Hydrogen is also a gas. Combines to form methanol. This is methanol. Methanol is a alcohol. Now number of carbon atoms, 1 in the left and 1 in the right hand side. Oxygen is 1 in the left and right also. Number of hydrogen atoms in the complex formula is 4. 3 plus 1. Three plus 1. 4 hydrogen atoms are there in the form of methanol or in the right hand side, on the right hand side. Now the H2 gas can be 2 moles to equalize the number of hydrogen atoms on both sides. So the overall reaction is carbon monoxide plus 2 moles of hydrogen gas combines to form methanol. At the given pressure, this is the unit of pressure, atm is the atmosphere. So the given pressure for this equation is 340 atmosphere. Next equation is the equation of photosynthesis. This is the equation of photosynthesis. Now the question in your mind should be how this equation is considered as the photosynthesis. So the reactions which are taking place in the presence of sunlight is related to the photo. Photo means light. And here is a synthesis of the food for autotrophs, that is glucose. This equation is the endothermic equation. How does it considered as endothermic? The amount of sunlight is entering or needed during the reaction. So we can consider this equation as endothermic equation. Now the carbon dioxide plus water gives glucose C6H12O6 plus water, extra water, and carbon dioxide, oxygen gas is released during photosynthesis. Now we need to balance the equation. Carbon in the complex formula, number of carbon is 6, so we have to put the 6 in front of carbon dioxide, 12 in front of 12 hydrogen atoms. So 12 hydrogen atoms can be by putting 6 in front of water molecules. Oxygen, 6 oxygen atoms. So the number of oxygen atoms are greater in the left hand side. So a total of 6 to the 12. 12 oxygen atom in carbon dioxide and 6 oxygen atom in water molecules. So total of 18 oxygen atom are there. So 6 oxygen atoms are present in glucose. 6 are present in glucose and O2 and H2O. Now how do we balance the equation? Now the third question is for you to balance this equation, that is the equation of photosynthesis, and answer the following question in the comment section. Hope so the hint is given will help you to find the answer of the question.